Data collection. Observations are interesting, sure. But other than that, what's the big deal? Observations are actually a very big deal. Data comes from observations, and data is a scientist's bread and butter. Without data, a scientist is just a guy or a gal in a chair watching the world go by. Data is the information that a scientist gathers from observations. Observations result in data. Data is gathered from activities of the senses. It's taken from tools in their readings. It's also collected as the result of experiments. A scientist keeps good records of all this data. When it's gathered, the scientist looks it over and studies it. She analyzes what it means. She interprets it to see how it supports or refutes the hypothesis. Or maybe the data gives the scientist a whole new idea. It may be time to start experimenting again. And it says, get organized. Be sure to keep your data together in one place, whether it's a notebook or a computer. You can't analyze data if it's only sticky notes in your cat's litter box. Okay, and then the pictures show a scientist carefully measuring a liquid and students who are gathering data from an experiment. Tell it. So now that you've observed, hypothesized, predicted, and tested, what do, oh scientist? Do now. You've got to tell others what you've learned and what you've done and what the evidence bears out. You could, of course, just keep it to yourself, but where's the fun in that? A scientist wants to know, and a good scientist knows that everyone benefits when information is shared. It's like this. The understanding of science builds on itself. What one scientist learns becomes the basis of another scientist's investigations, and those investigations support other scientists. The work grows and grows. More is learned, validated, or even disputed. There's always more to discover and uncover. There's always more to know. Scientists have worked like a team throughout history. The work of scientists from earliest recorded times carry forward to today. Today's work will carry forward through the future. Scientists come and go. What they learn lives on. Okay, long-term learning. Down at the bottom in the green box. Learning why something happens can take time. Some experiments take hundreds of years to complete. A longitudinal study is one that takes place over long periods of time. Researchers have observed the same variables many times, looking for what stays the same and what changes. It comes down to this. A scientist must be able to communicate findings to others. The information must be clear, organized, and precise. It also needs to be easily understood. Take, for example, Newton's first law of motion, which is a scientific truth. It states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted on by an unbalanced force. Wow, that's a mouthful. But what does it mean? It's not hard to understand, but it can be tricky to explain. What it means, simply stated, is that an object keeps doing exactly what it's doing unless something comes along to change it. Let's put that into practice. Say you're riding your skateboard and you're going along full stream ahead. Suddenly there's a rock in your path and you don't see it. Bam! The rock stops the skateboard dead in its tracks. But you keep sailing forward until gravity forces you down and an unfriendly sidewalk smacks you. Safety tip, always wear your helmet and pads, my friends. A scientist can use the skateboard story to help explain Newton's first law. You can understand it now, don't you? A good story always helps make things clear. Again, keep it simple. Occam's razor is an idea that says the simplest hypothesis is often the best hypothesis. Sometimes a question requires a complicated answer, but when you don't have a lot of time or information, it makes sense to keep the simplest answer first.